Okay, so today's lesson is called Geometric Mean. This is going on page 81 when we are finished. We'll get to the meaning of this here in just a little bit. But what this really relates to is similarity, but similarity specifically with right triangles. Okay, so when you have any triangle, all triangles have altitudes. Okay, so the altitude, now let's talk about the altitude is, the altitude goes from a vertex perpendicular to the opposite side. The altitude is the segment, the height is the length of the segment, and every triangle has 3 different altitudes that you could draw. So in a right triangle, a lot of times for the height, we'll just use one of the legs, and each leg could be counted as an altitude, but then there's a third one, and this is the one that we're talking about here. The altitude to the hypotenuse. What that means is like this right here. It goes from this vertex to the hypotenuse over here. That is what this is referring to. So the altitude to the hypotenuse of a right triangle forms 2 triangles that are similar to each other and the original triangle. So what you get here when you look at this picture, there are a total, there is a right triangle, and again, this could be considered the height, and this can be the base, or this could be the height, and this could be the base, or this could be the height, and this could be the base. There's always 3 options there. So this is the one that we're usually not using for area and things like that, but it's still the altitude, goes from the vertex perpendicular. It makes this picture to have a total of 3 triangles. Okay, and all 3 of these triangles are similar to each other, and because of that, we end up with some proportional things and some shortcuts to find lengths of these things and whatnot. So what's the easiest thing to do? Remember that when you have triangles and they're similar or they're congruent, that it's not always that the top angle corresponds with the top angle and the bottom with the bottom and the left with the left or whatever, but you can draw them to where they do. And if you can draw them to where everything is sort of facing the same way, it helps you visualize things a whole lot better. So we're going to take this, we're going to look at this as the big whole triangle first, and I'm going to put 1 little arc mark here and 2 here just so that we have all 3 angles in the big triangle labeled as something. And then we're going to separate and redraw these. So I'm going to redraw the original one, then a smaller version of it, and then an even smaller version of that. So it's like taking this apart, but turning them around and flipping them around so that they're all facing the same way. So in this case here, all the right angles would be on the bottom left, just like that. So they're all facing the same way. So the original triangle, this is B, this is C, this is A. We have 1 mark here and 2 here. So that's big. Right? So we'll call them small, medium, and large. So this is the large. This is the medium triangle. So I can tell by looking at the medium triangle that it has a right angle, and the right angle in the medium triangle is D. Change my colors here. Right? So the other 2 letters are A and C. Well, in the big triangle, you see how this is on the bottom right? I want that to be on the bottom right here. In the medium triangle, this is A, and that makes my 3rd letter C. So then in the small triangle, remember small, medium, and large, this one right here, the right angle in that one is also D. Then we have this angle right here, right, that belongs to the small one and the large one. And the large one is up here, so it needs to be up here for this one as well, and that would be B, which means this is C. So look at how you could think about taking this one off and basically reflecting it to get it over there and turning it a little bit. This one, basically slide it over and reflect it a little bit. But we could kind of turn these and we could cut them out and put them back together if necessary. So see how those all relate to each other. Now, of course, what this means is angles C here, D, and D here, all 3 of those angles are congruent. Of course, all 3 of these are congruent, even though this one isn't marked, and all 3 of these. So this one really does have 1 here and 2 here. Not really necessary, just so that you can see what corresponds to what. So once you take it out and redraw it, This can really, really help you with the relationships. Understand how to turn them around. If you just redraw it and it's turned the same way over here, that ain't going to help you any. So by doing this, I can say how all of these triangles are similar. Triangle ABC is similar to the medium one, right? So if it's ABC, once they're turned the same way, then I know it has to be ACD for this one. And triangle CBD over here. Okay. So, first thing we have to be able to do is identify the similarity relationships between these triangles. We know they're all similar by angle, right? These two angles congruent to these two angles, so the triangles are similar. These two angles congruent to these two angles, so the triangles are similar. Right? And we'll get to what this means for us as far as a measurement here in just a second. Okay, so I want you to try and do this. I'm going to give you a second. I want you to sketch the three triangles. Okay, this time they're turned this way. Don't try and turn them the way they are up there. Sketch the three triangles with the angles in the corresponding positions, and then write the similarity statements. I'm going to start the first one for you so that we can all kind of be consistent. We're going to call the first one RST. Okay? So let me give you a second. I am going to go ahead and try and pause this because hopefully now the video won't, or I'm not going to pause it. I want you to try and pause it because I think the video won't start over on you. I'm pretty sure that I have fixed that issue, but maybe not. So pause this for a minute. I want you to draw and label the triangles. Think about what we just did up there. And then write your similarity ratios. And then when you are finished, unpause the video and then see what I've done. Okay, so I'm going to assume that you actually paused and you did what you were supposed to do. So here's my large. Here's my medium. Here's my small. Of course, things don't have to be to scale, and the shape, you know, it doesn't have to be perfect, but it definitely helps you more the better things look. So I'm going to put, these are all my right angles. And then I'm going to put 2 here and 1 here, and it does not matter which is which, it's just some way to actually label them. All right, so my big one is RST. And I've got this and this. So then when I go on to the next one, my medium one, this medium one here, the right angle is P, so this has to be a P. My other two letters are T and S, and I've got to figure out which one goes where. Well, T is this one, so it's going to line up there, which means the other point has to be S. Then when I go to my small one, right angle is also P. Then this has the 1 mark on it, just like the top up here, so this has to be R. And then this is S. So you can see again that these are similar by angle. These two angles are congruent to these two angles, therefore these two are similar. These two angles are congruent, I'm sorry, not those two. These two angles are congruent to these two, therefore these two triangles are similar by angle. And then you can use the transitive property to say that these two are, so basically they're all similar to each other. But since I drew them where they're all facing the same way, makes it way easier to do corresponding pieces. So if the first one's RST, the second one is triangle SPT, and then the third one is RPS. Okay. All right, so that's how we figure out which pieces correspond. So we're going to talk about what geometric mean actually means, and then how all of this stuff actually fits together. So, you know what a proportion is. You've been doing proportions for a long, long time, and you're pretty good at them. So in this proportion, we have parts of the proportion, which you probably have never been told what these parts actually are. But proportions have what are called means and extremes, all right? And they are the things that you multiply when you cross multiply. So the top of the first one and the bottom of the second one, this right here, these are your extremes. And then these two, these are your means. Right? And it says, in this proportion, the means of the proportion are the same number, and that number is the geometric mean of the extremes. Okay, the geometric mean of the extremes. So I want you to think about what mean means in math. When you do mean, median, and mode, think about what mean means. Mean means average. Well, mean kind of means average here too, but this is geometric mean. It is different. The mean that you are used to doing with mean, median, and mode is actually the arithmetic mean. We just don't call it arithmetic mean because it was the only mean that you've known. So now we have to kind of say we have the arithmetic mean, which is when you add things up and divide by how many there are. And then we have the geometric mean, which has to do with a proportional relationship. Okay? So the geometric mean of two positive numbers is the positive square root. Okay, so we can only take geometric mean of two positive numbers. It is the positive square root. Because remember, when you take a square root, you've got two answers, a positive and a negative. We only care about the positive when we're doing geometric means of their product. So basically it means I'm going to take this proportion and solve it. So the geometric mean of A and B is the positive number A, as positive number X, such that when I cross multiply, X squared is equal to A times B. Or when I actually solve for X, X is equal to the square root of A times B. But remember, it is the positive number that you get out of there. So we're going to find the geometric mean. Here's how, when it's just pure, find the geometric mean, here's how you set it up. You set up two ratios to make a proportion. The geometric mean, remember the means go here and here. So you take the two numbers you get, and you put them in the other spots. So now you cross multiply. And you're going to get X squared equals 36, which technically means X equals plus or minus 6, but this is a geometric mean question. That is your answer. I want you to pause the video, and I want you to do the next two on your own, and then come back and look what you got. Look and see if you got what I got. Okay, so I'm going to assume that you paused it. Here's my proportion. So I get X and X. That makes this 6 and 15. So when I cross multiply, I'm going to get X squared equals 90. That is not a perfect square, but this does become 9 and 10. 9 is a perfect square. 10 is 2 and 5, and I can't do anything with that. So X is just going to be 3 square root of 10. If you haven't already done the last one, then pause the video, do that, and then come back and see what you got. Okay, so here's how I set this up. 2 and 8, it does not matter which one is which here. We get X squared equals 16, which means the geometric mean is 4. Okay. So let's look at how this is actually going to help us, because we're not just going to sit around and find a bunch of geometric means like what we just did. And look at how this applies to our triangles here. So what we're going to do is we're going to redraw these triangles again, like we have been. I'm not going to redraw the big one though, just due to space, but I'm going to draw the medium here, or I'll draw the small one here and the medium one here. So I'm going to start off by marking these just like this. And then just my big one is what it is right here. So I'm going to take the little one. There's my small one. Okay. And then here's my medium one. And this time I don't have the vertices labeled, but, oh, it would help if I did that. I don't have the vertices labeled, but I do have the pieces labeled, so we're going to see how those actually play out and relate to each other. So when I start with the medium one here, right, this is turned the same way as this one. So in the medium one, this right here is what has 2 marks on it. So in the big triangle, or my large triangle, B is one of the legs of the big right triangle. But in this medium triangle, this length that is B is actually the hypotenuse. And then the legs of that triangle are H and Y, and I've got to get them in the right spots. Well, Y is the side that's made up of the right angle and this angle. So this right here is Y, which means this has to be H. Okay, so I'm going to do the same kind of thing over here with this little triangle. Right? So A is one of the legs in the big triangle. But in the smallest triangle, it is the hypotenuse. This angle is right here because we're all going to be turned the same way. So the side length that goes between that angle and the right angle has a length of x, so this has to be x, which means this piece is h. So make sure before you move on that you understand how those have been taken out and turned around so it can make sense to you. So now we're going to look at how these similar triangles, because remember they're similar, so I can set up proportional pieces, how these work to give me what my rules are going to be in here. I don't want to just give you a bunch of things and this is how you multiply. You need to understand how this all works. So if I look at x in the little triangle, right? And now since I have turned them all the same way, all the corresponding pieces, like all the left sides correspond, all the bottoms correspond, and I know I've said a lot of times you can't just go top with top, bottom with bottom, but you can when you have drawn them that way. That makes it okay. That's what makes it easier. So I want you to look at x in the smallest one. What does x in the smallest one correspond to in the medium one? X goes with h. I'm going small to medium. I'm skipping over the big one. So that means I can put x over h. And then when I look at h in the smallest one, it corresponds to y in the medium one. So h over y. So this was small over medium with the corresponding pieces. Now I want to look at x in the smallest one and what it corresponds to in the biggest one. So x corresponds to a, so I can do x over a. Then I'm going to look at a in the smallest one. That's the hypotenuse. It corresponds with the hypotenuse of the biggest one, which is c. A over c. Then I want to look at y in the medium one. It corresponds to this part of the largest one, so it goes with b. So I'm going to put y over b is equal to, and then b, which is the hypotenuse in the medium one, corresponds with c, which is the hypotenuse in the largest one. Okay, so those are just proportions that we set up, just corresponding sides. Leg over leg equals leg over other leg. And then leg over leg equals hypotenuse over hypotenuse. And leg over leg equals hypotenuse over hypotenuse. Now if you look at this and you look at the explanation of a geometric mean, the geometric mean, these are the means, when these are the same, that's what makes them the geometric mean. So basically this part, h, is the geometric mean of these two. A is the geometric mean of these two. B is the geometric mean of these two. So when we cross multiply, ultimately what that gives us here is that h squared equals x times y. And here I get a squared equals x times c. And here I get b squared equals y times c. And the thing is that this is going to happen every single time. So you're not going to have to necessarily redraw these triangles every single time if you understand the relationships. And these words, this can be very, very wordy, but we already pretty much have it written down here. So what this says up here is the length of the altitude to the hypotenuse of a right triangle. So the length of the altitude to the hypotenuse of a right triangle, that in this case would be h, is, that means h is the geometric mean of the two lengths of the two segments of the hypotenuse. Well, the two lengths of the two segments are x and y. And look what we have here. H squared equals x times y. So h squared equals x times y every single time. If you have an altitude drawn to the hypotenuse of a right triangle, then since the altitude is the geometric mean of the two pieces, that means it's the altitude squared equals piece times piece every single time. The other theorem says the length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So let's talk about what that means. We have the hypotenuse and legs. This is a piece of the hypotenuse. It is adjacent to this leg. Y has nothing to do with A. X has nothing to do with B. C is attached to both of them. So it is the geometric mean. So if something is the geometric mean, that means that thing squared. So the length of a leg of a right triangle is the geometric mean. That means A squared has to equal something, and B squared has to equal something, because they are geometric means. A squared equals the piece that's attached to it times the whole thing. That's X times C. B squared is the piece that's attached to it times the whole thing. That's Y times C. These are exactly what we got down here by setting up a proportion given the proportional sides. So, worst case scenario, you get the rules mixed up, but you can redraw the triangles and label things. Then you can get the pieces there that you need. But in the end, the relationships are really, really not that bad. You just have to, it does matter how you do them. Okay, so altitude squared, this right here divides the hypotenuse into two pieces. So this squared equals the two pieces multiplied together. A squared is attached to X and it's attached to the hypotenuse. B squared is attached to Y and it's attached to the hypotenuse. So B squared equals the piece times the whole thing. A squared equals the piece times the whole thing. H squared is just equal to the two pieces multiplied together. So once you do a few of these, it's not nearly that bad. But listen to what I'm telling you as you go through this and the examples. Okay, so let's do the first example here. We're going to find X, Y, and Z. So we've got a bunch of things to set up. Set them all up before you do anything. Do not set one up and start working it, because that does not work out too well for you some of the time. Plus, depends on what information you have. So I'm going to start with a leg. This is a leg. The leg squared is equal to the piece that's attached to it times the whole thing, right? So the whole thing here is 12. So the leg squared, Z squared, is equal to the piece that's attached to it times the entire hypotenuse, which is 12. That's my first setup. I'm not doing anything, even if I'm capable. Then I'm going to do the altitude. The altitude squared is equal to the two pieces multiplied together. So I know then that X squared is equal to 2 times 10. And I'm not working anything out yet. I'm doing them horizontally just like this so that I can get everything down, because sometimes you can't just work each one out separately. Then I have the other leg. So that's another leg squared. Leg squared equals the piece that's attached to it times the whole thing. So this time it is 10 times 12. So after you set it up, then you've got to decide, okay, where's your information and how are you going to know what to do? Well, you actually have enough information on all three of these in this particular case to work each one of them independently. So I'm going to take this one, and I have this, this, and this before I do anything else. Then I'm going to work them out. So here this gives me Z squared equals 24. That means Z is equal to the square root of 24. Do your factor tree, and Z equals 2 square root of 6. Okay, then I can move on to X squared. So X squared is equal to 20. That means X equals the square root of 20. Do the factor tree if necessary, and you get 2 square root of 5. Okay, then we have Y squared equals 120. So Y is equal to the square root of 120. So do your factor tree if necessary. You get Y equals 2 square root of 30. Okay. Now, they are not all going to work out so nicely where you can just do them in any order that you want. So let's look at the next one. Remember, you can always pause and rewind whenever you feel the need. So we're looking for U, V, and W, and we know that we have to use the legs, we have to use the altitude, the pieces of the hypotenuse, and we need the entire hypotenuse. So the entire hypotenuse here, think about what that is. It is not 3U. When we did this up here to get 12, we did not multiply 2 times 10. We added 2 plus 10 to get 12. So here, when I add u plus 3, what do I get? I get u plus 3. It's as good as it gets. All right, so let's start with w. It's a leg. Leg squared is equal to the piece that's attached to it, which is u, times the whole thing, which is u plus 3. Do not do anything until you have all 3 written down. Don't do anything. So then I move on to the altitude. Altitude squared, so this is 9 squared. That's equal to the 2 pieces multiplied together, u times 3. I do not do anything until I have them all written down. Legs, this is a leg, so leg squared is equal to the piece that's attached to it times the whole thing, which is u plus 3. Okay, don't start multiplying a whole bunch of things out until you look at this, and now I look at each one of these. This has 2 variables, this has 1 variable, this has 2 variables. So I'm starting here. So I'm going to start here. 9 squared is 81. That's equal to 3u. Therefore, u equals 27. Now, again, before I multiply things out, I'm going to substitute. Now I know what u is. U goes there and there, and u is going here. So now I have enough information over here, and I'm going to get that w squared is equal to 27 times 27 plus 3. I'm still not distributing. I can add this, so I get w squared is equal to 27 times 30, which means that w squared is equal to 810. So w is equal to the square root of 810. So I can do my little tree. This is 81 times 10, guys. 10 is 2 and 5. That's a perfect square. So in the end, there's nothing else I can do with that. W is equal to 9 square root of 10. Okay, now I'm going to come over here, plug 27 in over here. Get b squared equals 3 times 27 plus 3. So v squared is equal to 3 times 30. V squared equals 90. V equals the square root of 90. This is 9 times 10. So v is equal to 3 square root of 10. There are my 3 pieces. If you do it methodically and do it in the order in which I'm telling you to do it and the way I'm telling you to do it, this is not nearly as complicated as some of you are going to make it out to be. Okay? All right, so let's go down to C. All right, so it says I want to find A, Y, and H if B equals 6 square root of 3 and X equals 6. So I've got those. So I'm not actually using B and X anymore. I'm going to use these others. Now remember, I need the legs, the altitude to the hypotenuse, the 2 pieces, and I need the whole thing. The hypotenuse is not 6y, it is y plus 6. Okay, so I go through this piece by piece and step by step. I'm going to get leg squared, so 6 square root of 3 squared equals the piece that's attached to it, which is 6, times the whole thing, which is y plus 6. 6 times y plus 6. And I stop. I do nothing else until everything is done. Then I get h, that's the altitude, so h squared is equal to the 2 pieces multiplied together, that is 6 times y. I do nothing until everything's written. My other leg is a, so that's going to give me a squared. That's equal to the piece that's attached to it, y, times the whole thing, which is y plus 6. Now, all 3 of them are set up. Then I evaluate. Which one do I have enough information for to go forward with? This has two variables, this has two variables, this only has one, so I am starting here. You have to be able to multiply 6 squared to 3, or figure out 6 squared to 3 squared correctly. Go back to your radical notes at the very beginning of your ISN if necessary, but this kind of thing is going to come up a lot and you cannot miss it every time. If you put it in the calculator, I can almost guarantee you're going to get it wrong because you're probably not going to put it in the calculator right either. So when you do this, that means what you're doing, I'm going to write down some extra steps than what you might normally write down just so I don't lose you. That means that when I square this, I am squaring 6 and I am squaring the square root of 3. That's going to be equal to, now here I am going to need to distribute, so it's going to be 6y plus 36. 6 squared is 36. The square root of 3 squared, think. Anytime you square a square root, you just get what's underneath it. The square root of 3 squared is 3. That's equal to, again, 6y plus 36. Okay, so 36 times 3. 3 times 30 is 90. 3 times 6 is 18. So this is 108 equals 6y plus 36. So then when I subtract 36 from both sides, think about what you get. I get 72. That's equal to 6y. So y is equal to 12. Now I'm going to take y, and I'm going to plug it in right here, and right here, and right here. I'm not going to even distribute that yet. It is totally not necessary. So now when I do this, I'm going to get h squared equals 6 times 12. So h squared is equal to 72. So h is equal to the square root of 72. Well, two numbers that multiply to give you 72, you know them right here, 6 and 12 if you need to, but this is also 36 times 2, if you recognize that. So h is just 6 square root of 2. All right, so then I move over here. A squared is equal to y, which is 12, times y, which is 12, plus 6. Still don't need to distribute. You could, but why make it harder on yourself? So 12 times 18. So a squared is equal to 216. So a is the square root of 216. Two factors of 216? Well, right there, because that's how you got it. So this is 12 times 18. You keep going. 9 times 2. 3 times 4. Right, you got two perfect squares there and two prime numbers. So a is going to be equal to 6 square root of 6. Keep going with the tree if you need to. Not all of you necessarily need to. Showing your work here is imperative. Not skipping steps to where you confuse yourself. Not getting ahead of yourself. Not just trying to, distribute things like this when it's totally unnecessary. Set it all up. Write down, do what you can do, plug it back in, think about what you're doing. This is not nearly as bad as what some of you will make it out to be. And usually when people are confused, it's because their work is total chaos. They haven't done what I've told them to do. Nothing is labeled. Nothing is written down. There's no wonder you're confused. So think through this. You can watch the examples again if you need to, but get this glued in, get your homework, help each other. Think about what you're doing, because whining and complaining about it isn't going to do you any good. You are totally capable of this. It's just not something you've seen before, so now you can't just half listen to it. Okay? So do your best.